right, so for this first one, it says find the value of x. As you can see that we have all these measurements of angles inside. So those are interior angles. So I have 1, 2, 3, 4 sides. So the number of sides n equals 4. To find the sum of the interior angles, I say n minus 2 in parentheses times 180. 4 is n, so I'm going to plug the 4 in for n. And then I do the work inside the parentheses. Remember, please excuse my dear Aunt Sally. While there's parentheses, that's the first thing, so I got to do the work inside the parentheses before I do anything else. So 4 minus 2 is 2. Then I'm just going to bring everything else down. 2 times 180 is 360, so that means when I add all these things up on the inside, it'll equal 360. So I'm going to say 360 is equal to x plus 55 plus 109 plus 76. Oh, I thank you. And so now what do I do next, guys? Yeah, I'm going to add up the like terms, right? So I'm going to turn on my handy-dandy calculator.
I see you, Mr. Adams. My calculator just went out.
I mean, I'm just trying to live my best life, you know what I'm saying? I'm just out here. Plus 76. All right, so this is 240, so we got 360 is equal to x plus 240. Subtract 240 from both sides. All right, so what's 360 minus 240? 120. Come on, get on my level. So it is 120. We just double check to make sure. So x is equal to 120 degrees. Any questions? How many of you guys got that? I saw some of you guys were working ahead. It'd be easier to write down if you put that big stuffed animal away.
Chico said that was disrespectful. You're peaceful.
Anyways, we're moving on to the next one. So now this one, if I'm thinking about an exterior angle, I'm going to rotate around. When I make one full revolution, that's 360 degrees. So since these are on the outside, I'm really making one revolution around. So all this stuff, in other words, 5x plus 76 plus 4x plus 56 plus 75, that will always equal up to 360. Now, one thing that I said, but I'm not quite sure if you guys are 100% on this, is I said this applies, some of these things that we're doing, they apply to convex polygons only. I don't know if I've emphasized that enough. This is not concave. This is not concave. Concave folds in on itself is the easiest way to say it. These are convex polygons. They don't fold in on themselves. So that's where these rules apply, okay? So anyways, I'm going to combine like terms. 5x and 4x are the only terms with the x, so I'm going to combine those. 5x plus 4x is 9x. Now I'm going to combine positive 76 plus 56 plus 75. Now, if I were to solve this, I could subtract 76 from both sides, I could subtract 56 from both sides, and subtract 75 from both sides. Or I could just combine like terms on the left-hand side of the equal sign one time, and then move that whole number over. Okay, so I'm saving myself a step by combining like terms on the left. Wow, with the new lights, look at how good that looks, huh? So I'm going to say 76 plus 56 plus 75. All that adds up to 207. It's a positive 207, so I'm going to say plus 207. And that's equal to 360. What do I do next? I'm going to subtract 207 from both sides. These will cancel. I'm left with 9x is equal to, so I'm going to say 360 minus 207, and I get 153. Now what do I do? So, yep, I want to get x by itself, so I got to move the 9. To move the coefficient of 9, I divide by 9. Whatever I do on one side, I do to the other. 9 divided by 9 is 1. 1 times x is x. 153 divided by 9 is 17. Okay? And that would be just the plain old 7. So yesterday, somebody, I think it was this class, said, was it 17 degrees, or is it 17? This is a value for x. See how they write 4x degrees? Because we're solving for x, it's just a value, so we don't label it as degrees. But up here, we had x degrees. Technically, I don't need to put the degree sign here, but it's good that you guys are thinking about it, okay? All right, for problem number 3, I know that this is congruent to this and that this is congruent to this. I know that. Okay, why? Because they told me it's a parallelogram, and I'm asked to find x and I'm asked to find y. So it says find the values of x and y in this parallelogram. Blah, 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 blah. So I know that y is equal to 10. So let's write this out a little more formally. AD is equal to BC. Well, actually, that's y. We've solved that one. So now AB, though, is equal to DC. So A is x plus 9, and DC is 28. I'm going to subtract 9 from both sides. Well, bam, with the bacon sizzle, I get x equals 19. Are there any questions on that? Now this one, if we wanted to be technical, I could say 19 units, because I don't know if it's 19 inches, I don't know if it's 19 miles. It's a measurement of length. May I turn the page? Yes? How many of you guys prefer that we review the same stuff over and over? That helps, doesn't it? Okay. You're welcome. All right, so this type of parallelogram, remember that these are, if it's a parallelogram, then this line, if you extend it out this way, and you extend this one out this way, those are parallel lines, right? And then this is like a transversal, isn't it? So these are consecutive interior angles. What do we know about consecutive interior angles? No, they're not congruent. They are, what do they add up to? 180, okay? So basically, the measure of angle D, we know that the measure of angle A is 68 degrees. So I'm going to subtract 68 from both sides. Well, bam, with the bacon sizzle, 180 minus 68. 112 degrees is the measure of angle D. Now I'm going to write it right in here, 112. And I want to warn you guys about this. The software that Mr. Adams uses is pretty good. Sometimes these aren't drawn to scale. So this looks like 68 degrees, this kind of looks like 112, but sometimes it won't look like it's supposed to. You got to trust the numbers and the math. They just have like a picture of a parallelogram, and they don't, sometimes they don't pay attention. Okay? All right, moving along. It says, for what values of x and y is quadrilateral ABCD a parallelogram? Well, for it to be a parallelogram, what do I know? Well, AB is equal to what? DC, that's good, right? And then, okay. So, if that's the case, what's AB? AB is 6x plus 24. And what's DC? 2x plus 32. So now what do I do? I'm going to subtract 2x from both sides. 6 minus 2 is 4, so I'm left with 4x plus 24. On this side, these cancel, and I'm left with 32. Yep, we're going to subtract 24 from both sides, and I get 4x is equal to 8. Is that right? And then divide by 4 on both sides, and x equals 2. Now, on the next one, BC is 5x plus 25 is equal to 6y minus 13. But what do we know x is? It's 2, right? So I'm going to plug in the 2 for x. This becomes 10. 10 plus 25 is what? 6y minus 13. That's a y, not an x. So then I'm going to add 13 to both sides. 48 equals 6y. What do I do next? And what's the answer? Y equals 8. Any questions on that? All right. For problem number 6, 6, 7, and 8 are dealing with well, technically, I think you're supposed to say rhombi, but it's rhombus. A rhombus is a very particular type of parallelogram. And basically, on a rhombus, there's a couple things that happen. One, the diagonals bisect each other, as all parallelograms diagonals do. In other words, that this length is this length, and this length is congruent to this length. But they're also angle bisectors. In other words, this angle is congruent to this angle, and this angle. Thank you. But all those angles are congruent, and then this one is congruent to this one, and then this one is congruent to this one. So right off the bat, the measure of, oops, let me use my pencil. The measure of angle 1 is 90 degrees. The measure of angle 2, if this is 53, then this is 53. Now to find the measure of angle 3, how could I do that? Well, I could think of this as being one small triangle, right? So if I think of that, then I know that the measure of angle 1 plus the measure of angle 2 plus, let me write that a little better, plus the measure of angle 2 plus the measure of angle 3 equals 180. What's the measure of 1? 90 degrees. What's the measure of angle 2? 53 degrees. We still don't know what the measure of angle 3 is, but we know it adds up to 180. Combine like terms, this becomes 143 plus the measure of angle 3 equals 180 degrees. So I'm going to subtract 143 from both sides. So I say 180 minus 143 equals 37. So the measure of angle 3 equals 37 degrees. All right? Now, that's 37 degrees, but, what do I know about the measure of angle 4 and the measure of angle 3? Because this diagonal is an angle bisector, angle 3 and angle 4 are congruent. So angle 4 is also 37. And the reason I know they're congruent is because this is 53, this is 90, so it'd be the exact same problem over. Right? Now we got to do the same thing here. So this is funny, like if you think of this, there's so many ways that you could solve this, but if you think of this as like these are parallel lines, and this is the transversal, what's the measure of angle 1? Those are alternate interior angles, aren't they? So that would be 80 degrees, right? Does that make sense? What's the measure of angle 3? 80. How do I find the measure of angle 2? By the way, if this is 80, this is a rhombus. So then we know that the measure of angle 3 is 80. We know that the measure of angle 1 is 80. We also know that the measure of angle 5 is 80, right? So to find the measure of angle 2, that would also be equal to the measure of angle 4, correct? So one way I could do is I could just add these up or just add these up. It doesn't really matter. I'm going to do this triangle. If I say the measure of, oops, let me slide it up a little bit. The measure of angle 4 plus the measure of angle 5 plus, what I'm doing is I'm trying to find the sum of these angles in here, plus 80 degrees is equal to 180. But what did we say the measure of angle 5 was? 80, right? So then I'm going to say the measure of angle 4 plus 80 degrees plus 80 degrees equals 180. What do I do next? Combine like terms. 160 equals 180 plus the measure of angle 4 subtract 160 from both sides. So the measure of angle 4 is equal to 20 degrees, right? 20 degrees. So then what's the measure of angle 2? 20 degrees. Now those are all properties of parallelograms. If this is 20 degrees, then this is 20 degrees. Right? This is the new stuff. So if these last two problems are the ones that are kind of throwing you off a little bit, they should. It's the new stuff that you're learning. Okay? Can I move on to the next one? Okay. Last one. So here's an interesting thing. Angle 1 is congruent to angle 3. By the way, it's a diagonal, so it's also congruent to angle 2. What is angle 5? 150. All right, so let's write this out. The measure of angle 1 is congruent to the measure of angle 3, which is also congruent to the measure of angle 2, which is also congruent to the measure of angle 4. We'll get to that in a second. But we know off the bat that the measure of angle 5 is equal to 150, because this is congruent to this. Okay? So now it doesn't matter which triangle I choose. I'm going to choose this triangle. So I'm going to say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Not 2. One of them is 150, right? So now the trick here, so what I'm doing is I'm finding these measures using this smaller triangle. But what do I know about angle 1 and angle 3? They equal each other. So what I'm going to do is I'm going to substitute. I'm going to say the measure of angle 1 plus the measure of angle 150 degrees, and then plus the measure of, now I'm going to substitute in, for the measure of angle 3, I'm going to substitute in the measure of angle 1, because they're the same, correct? Now, it's a kooky way to do things, but what I now have is I have how many measures of angle 1? 2. Well, if I had x and x and I added them together, what would I have? 2 times x. So I'm going to say 2 times the measure of angle 1 plus 150 is equal to 180. So I'm going to subtract 150 from both sides. And I get 2 times the measure of angle 1 is equal to 30, correct? What do I do next? Divide everything by 2. 2 divided by 2 is 1. 1 times this is the measure of angle 1. 30 divided by 2 is 15 degrees. So now all these angles up here are equal to 15 degrees. The measure of angle 1, the measure of angle 3, and the measure of angle 2, and the measure of angle 4, they all equal 15 degrees.